What's up, guys? It's me, Sir Ernest, and today we're going to discuss impulse in collision. In our previous examples or discussions, we talked about the conservation of momentum. Again, the context here is the momentum that we're talking about is linear momentum. Okay, and it states that the momentum before and after collision are the same. So if this is the total momentum of the system before, this is always equal to the total momentum of the system after collision. Okay, so that means the change in momentum, so that's P1F minus P2F, P1F minus P1I is equal to negative P2F minus P2I. So that means whatever the change in momentum brought up change of momentum of the second particle, that is equal to the change in momentum of the first particle. Okay, now what is this change in momentum? This change in momentum can actually quantified when we look at what happens during collision. Okay, so during collision, so you will notice that they are physically interacting with each other. So that means during collision, there is some form of force that arises during this interaction. We call this impulsive forces. These impulsive forces are forces of extremely short duration, and they are typically exerted by the particles involved during collision. Now let's say consider one particle. One particle is subject to this impulsive force. Let's just call it F. So that means the equation of motion will now be equal to the change in momentum of that particle with respect to time. So by definition, this will be the time derivative of the product of the mass and the velocity of one of the particles. Now this, you will notice that this equation can be converted to be an integral equation in this form. F dt, this will be equal to m times dv. And then we take this integral both sides. So this integration happens between T1 and T2. So T1 and T2 would be the period at which the particles are colliding. So T1 is the time that the collision starts. T2 is the time when the collision ends. And during this time, this has an initial velocity. So this is the velocity before collision, and this will be the velocity after collision. So let's call this vi, and this will be vf. Okay, so we call this term to be the impulse. In your book, it's written to be capital P. Okay, and this will be equal to, as I mentioned, this will be equal to F the integral of f dt from t1 to t2. This force function is a function of time. So if we're going to track, for example, if we take the graph of the application of the force as a function of time, the impulse, so let's say this would be your time, and this will be your f as a function of time. The collision happens from t1 to t2. So as you will notice that the moment the two objects starts to collide, okay, so there is some the force that they are excited with each other would start to increase, and then it will reach a peak number or peak value, and then after this time the two particles will start to move away from each other. Okay, so this area under the curve would be the impulse during the object. And this impulse, as you will notice, going to look at the other side of the equation, this part would be m times vf minus vi, or m delta v, or this is the change in momentum of the object. Okay, so in other words, the impulse is actually defined to be the or equal to the change in momentum of the particle that undergo this collision. And numerically, or in terms of magnitude, this is equal to the change in momentum of the other particle involved in the collision. Okay, so that's it. This is the impulse. This is impulse during collision, and in the coming videos we're going to apply the concept of impulse and momentum in various problems in our textbook. So for now, thank you guys for watching. I hope you learned something today, and I'll see you guys in the next video. Bye bye.